Hello, welcome to our fourth webinar on photographic process identification funded by the National Endowment for the Humanities. I'm Alice Carver-Cubic and I am a research scientist here at Image Permanence Institute. This webinar is indeed being recorded and it will be available online. In today's talk, I will present a methodology for identification with a vocabulary specific to identifying characteristics of photographs. This is intended to pull together the information presented in the previous webinars, but with a focus on key identifying features of photographs, how to look for them, and recognizing identifying characteristics when you see them. This is the first part of a two-part series. In part 2, presented next month, I will show you how to use this methodology and this vocabulary with Graphics Atlas for identifying photographic processes. The intention of having a methodology and vocabulary for identification paired with a reference resource like Graphics Atlas is to simplify process identification and hopefully to make it easier. So as a comparison, if you were in the forest and you wanted to identify a plant, you might look for key identifying features of the plant, like the shape and color of the leaf or the shape of the stem. You would then probably pull out your reference guidebook, which would then help you to identify that specific plant. We can take this example and we can apply the idea to identifying photographs. Instead of looking at a leaf, the color and the structure, we're looking for characteristics specific to photographs, like image color. So as we go through, go ahead and ask questions as they come up, and I'll answer all the questions at the end, or as many as I can anyway. So many of us have experienced that process identification can be really challenging. Each process from 1839 to the present uses different materials and different technologies. However, many of these photographs have similar visual characteristics, making it difficult to properly identify the process. This makes process identification kind of overwhelming. For example, shown here are 4 different photographs made using 4 different processes. But as you can probably see, the color of the image in each is nearly identical. I will show you how to break down process ID into steps, making it simpler and less overwhelming. Using the process identification methodology, we will see that each of these photographs also have features that are different from one another. Next month, using Graphics Atlas, we'll put all the pieces of the puzzle together, or these key identifying features together, to identify these processes. So each process has unique features that are a result of the materials and technologies used to make the object. These are called their key identifying features. So while 2 processes might have some common features like image color, they will have other features that differ. We have to consider all the features together to arrive at identification. As we go through, when we talk about things that are key identifying features, look for this little fingerprint. So what are key identifying features of photographs? The features we're looking for are image color, surface characteristics like surface sheen and texture, and finally image structure and layer structure. But how do we go about making these observations? We break down identification into bite-sized pieces. There are 3 methods of looking. There's the object view, the surface view, and the magnification view. With each view, we will look for specific identifying features that can only be seen with each view. So we'll begin with the object view. Here, we're looking for features that are visible with even illumination and no magnification. That is, what can you see by just looking at the object? No special tools or techniques required. I want to quickly give a shout out to Erin Fisher, who is pictured here. She's a recent graduate from the University of Rochester Photographic Preservation and Collections Management Master's Program. She used our IPI study collection for her master's paper and graciously agreed to demonstrate the identification methodology for this presentation. Thanks, Erin, and Erin is absolutely fantastic. Okay, so back to the subject at hand. The object view is the only view in which I will discuss things that you can look for that are not really considered key identifying features, but might actually help you to narrow down a date range for your object. When I introduce a key identifying feature, again, I'll put the little fingerprint in the corner of the slide, and I'll be sure to point those out when they come up. So the first thing you might want to look at is the image itself. Photography is meant to make images, so let's look at the picture. When approaching identification, we often forget to look at the picture and we jump straight for the microscope, but be careful not to do this. Definitely take in the image. Are there clues within the image itself that might narrow down a date range, which in turn might narrow down what the process possibilities are? Here, we are not looking for key identifying features, but rather just good clues that might help us better understand the object. So image clues might be clothing, vehicles, hairstyles, or buildings. In this particular image, we see three girls with bicycles. If we know a little bit about clothing, we might say, oh, these dresses look like they're maybe turn of the last century, maybe 1890s or into the 19-teens. If we know something about bicycles, or we can just look up information about bicycles, we might see that these are called safety bicycles, which replace the bicycles with the giant wheels. We know that the bicycle craze sort of started in the 1890s, so we can say, okay, this is at least 1890s or later. So yeah, there you go. Just some clues within this particular image. Format is also not necessarily a key identifying feature, but may narrow down a date range. In the 19th century, there were some popular formats like the carte visite and the cabinet card. Folders and postcards were popular in the early 20th century. Be careful though, a carte visite is not a process, it's a format, and any process can be in this format. I've seen everything from salted paper prints to silver gelatin developed out prints as cartes de visite. The same rule goes for all of these other formats. So here are our 4 prints again, but here we can see the entire object. What are the image clues telling you about when they might have been made? Without seeing these objects in person, it's hard to tell exactly what the format is, so I'll walk you through each object. Judging by scale, you may have guessed that object number 1 is a carte visite. The woman's clothing suggests maybe mid-19th century. Object 2 is about 5 by 7 inches, and the hairstyles and clothing of the sitters suggest probably mid-20th century. Object 3 is mounted to a card mount, but it's not a cabinet card, it's slightly smaller. These cream mounts with the decorative edges and the mounts of varying sizes were popular in the late 19th century. This information, combined with the child's outfit, suggests 19th century, but maybe late 19th century. The 4th object shows a person in costume, which makes it difficult to judge a date. It's mounted to a thick piece of paper. Keep in mind this exercise is merely a way to narrow down a date range, which in turn will narrow down the process possibilities. If you don't know a lot about formats, or you're not really confident at judging dates by clothing, or if your image is something like a landscape, don't worry. There are many other things we will look for that are really better indications of process that are these key identifying features. Another thing to look for is any information written or printed on the object. For example, is it dated on the back? Here are objects 3 and 4, details of objects 3 and 4. 3 has the photographer's studio information embossed on the card mount. Object 4 has a lot of information printed on the object or on the mount. There's a quote, the name of the actress, a date, the name and address of the photographer, the name of the theater, and finally it says Woodbury type. If you can see right here in tiny type, it says Woodbury type. So there you go, our process is identified for us. Woodbury types sometimes have the process name printed on the mount, but not always. So we'll keep looking at this object so you'll know the other key identifying features for it. So we won't give up here. Other photographs may have a back stamp or back print. Here are the backs of 2 photographs. The one on the left is stamped with the name of the company, the product, and it's dated. The one on the right has the company and product name. This is only really seen in 20th and 21st century prints and products, but again, it's a good indication of what the process might be. You can always, Google Kodak Extra Life. So now what we want to do is we want to observe what the support material is. This is a key identifying feature. See the fingerprint? Again, it's more difficult for you to do this by looking at my slide, but likely if you have your object, your collection in hand, you'll know what the support is. The support of the photograph itself is referred to as the primary support. If it's mounted to a thicker card mount or paper, the mount is referred to as the secondary support. If the photograph is mounted, the primary support is probably paper. Paper is by far the most common support for all printed media. All of our examples are on a paper support. All of our examples also happen to be mounted to a secondary support. Obviously that won't always be true, but the examples that I've chosen are. If your object is not on paper, this is another way to narrow down the possibilities. Glass was popular in the 19th century and early 20th century for just a few very specific processes, like all the wet plate collodion processes and gelatin dry plate. Metal support is probably a daguerreotype or a tintype. Contemporary processes like inkjet can also be made on metal, but hopefully you'll have a sense of the object and kind of the object's age if you encounter one of these. Cloth was used at the turn of the last century. It was sold pre-sensitized with printing out chemistry and ready to use. Cyanotype, as well as other iron-based processes, can also be printed on cloth. There are cloths available for inkjet printing, but again, hopefully you'll kind of have a sense of what that object is and the age of that object. Because paper is the most common support, identifying photographs with paper support will be our focus as we go forward. Now we want to look at the color of the image itself. This is also a key identifying feature, fingerprint. Most prints are either monochromatic, that is one color, or full color, aka chromatic. Monochromatic prints can be further broken down into four main colors: black, purple-red, brown, and yellow. Yellow is the color of silver image deterioration, but it's fairly prevalent in collections. It's usually accompanied by fading, appearing as loss of detail in the highlights and midtones. This visual identification guide is available on Graphics Atlas in the Search tab. We'll discuss how to use the search function next month, but I encourage you to log into Graphics Atlas and take a look at it. I want to give another shout out. I want to give a shout out to Stephanie Hoffner. She's also a recent graduate of the Photographic Preservation and Collections Management Master's Program. Stephanie was an intern here at IPI, and then she was an employee, and she was absolutely instrumental in developing this methodology as well as these visual guides. Steph is also absolutely fantastic, and I could not have done any of this without her. So thank you, Stephanie. Steph and I used IPI's large study collection and reorganized a large portion of it by color rather than by process. These four monochromatic colors that are the colors that emerged. We also found that some photographs could be a range of other colors, although this is less common. So here we have all of these other colors. The most common color is blue of the cyanotype. However, other things can be blue. Also, we found that there's full color prints with our color processes, but we also found, monochromatic photographs can be hand colored. And so be careful not to confuse a hand-colored photograph with an actual full-color print. So we just sort of added hand color down there as well. As a reminder, the color of the image is the result of how the image was formed and what the image material is. Image material in photographs can be metal, pigment, or dye. Inkjet prints and photomechanical prints are made with ink, but the colorant is dye or pigment, and that's sort of what's left. Silver is the most common image material for monochromatic prints. As you can see in the 19th century, silver-based photographs, the image can be many colors. The printed out silver image is composed of very small particles of photolytic silver, which starts out after you print it as a sort of brick red color and then is toned with gold. Some of the silver is replaced by gold, which then gives you this range of purple-red image tones. However, they can also become yellow due to silver image deterioration. So here's kind of a nice range of image tones here in that purple-red area, but this last one is yellow because the silver image has deteriorated. The exception is matte collodion. It's toned with both gold and platinum, giving black image tones, or it could be toned with only gold or only platinum, giving purple or brown tones respectively. But remember here, image clues are actually helpful. Matte collodion was only available from 1890 to 1915. The image stability is also key. Matte collodion are less prone to image fading due to the platinum and gold toning. Untoned silver developed out prints from the same time period will often exhibit image deterioration. Developed out silver prints are often referred to as black and white because they have these black image tones. This is due to the large filamentary silver image particles, but they can also be toned brown or purple-red. Untoned developed out silver prints can deteriorate and can become yellow or yellow-brown in tone. This last image was made about the same time as the matte collodion printed out print directly above it. The developed out print below has faded and has become more yellow in tone. So that's just sort of a comparison between the stability of the two. The most common image colors for platinum are brown and black. Pigment prints, the pigment can be any color, but the most popular monochromatic colors were black and purple-red. Pigment could also be used to make full-color prints. The pigment processes of the 19th and 20th centuries are the dichromated colloid processes. These are the ones in which the binder, usually gelatin, hardens in proportion to the amount of light received. So while these can be any color, there are other clues to look for based on image formation and image material. And finally, prints in which the image material is dye are usually full-color prints. So going back to our example objects, here's object number 3. We can compare the image of this print to our chart. But first, I have a few really important tips that I want to give you for judging image color successfully. First, be sure your light source is daylight balanced. You can purchase a daylight balanced bulb for a desk lamp or get daylight balanced bulbs for your light fixtures in the room, or you can buy a special lamp like an OttLight or something like that. Fluorescent and tungsten lights have a color to them that skews your perception of the image color. You're probably accustomed to the color of light in the room, and you may not notice that everything looks slightly green in a room lit with fluorescence, for example. Evaluating color is extremely more successful with a daylight balanced light. So when we look at this image here, these 3 images, on the top left we have our daylight balanced light. We have 3 photographs and our color checker imaged with daylight balanced light. And we can see, especially when we look at the color checker, the colors look good, everything looked right. When we look at the image, the same setup with fluorescent lighting, we can see that everything has kind of a greenish or kind of yellow-green hue to it. We look at our color checker and all the colors seem a little off. And then below, we have the same setup with tungsten lighting. Tungsten light gives everything kind of a magenta cast. And you can see down here, our color checker has kind of a cast to it. If anybody has ever used color photographic film, you'll remember that you had to buy daylight balanced film if you were going to be shooting in daylight, but if you knew you were going to be shooting in tungsten light, there was actually film that was balanced for tungsten light. If you used the daylight balanced film in tungsten light, everything was this color, right? Everything was this kind of magenta color. So yeah, daylight balanced light for looking at image color is essential. The next trick is to look at the darker midtones and shadows, ignoring the highlights. The paper itself has a color, and the highlights themselves have a color. The highlights may be bright white, or buff, or cream white. They can even be pink or blue, which will also skew your perception of the color of the image itself. Also, deterioration, particularly of silver images, occurs first in the highlights and lighter midtones. Therefore, the print may actually be more than one color. It may be yellow or brown along the edges and more purple-red in the center. What you can do is you can use an index card with a hole punched in it to isolate the darker areas of the image. So in our example, print number 3, you can see that we just want to look at this child's clothing where we have some darker midtones and some shadows, and we're going to ignore the highlights. So this object, as well as all of our other objects, fall within this purple-red range. You can see we even have this guy as one of our object examples in our guide here. If you're going through this exercise and you're not sure about the image color, don't stress it. Just make your best guess. Again, daylight balanced light will make this exercise easier. The color bar under the images in the guide represent the image tone, ignoring the color of the highlights. So you may actually want to compare the color bar to the midtones of your print. And I totally recognize that when looking at this chart, where does the left end of brown and the right end of purple red, where does one end and the other begin? Again, it can be kind of subtle. So with daylight balanced light and just going with your gut is the best way to go. Seriously, don't stress it. Image deterioration can also lend some clues. This can be a key identifying feature for some processes. We've also created a guide for image deterioration. So the color balance of some prints can shift. Highlight yellowing is common for albumin prints as well as chromogenic and some instant prints. Platinum or platinum tone images can exhibit what's sometimes called image ghosting. And finally, silver images and color images can fade. So back to our objects. Object number 1 has some minor image fading, which is happening around the perimeter first. This is common in printed out prints. Although it's difficult to tell in my image of this object, the highlights of this print are slightly yellow. To determine this, put your print up next to something that is actually really bright white, like copier paper. If the highlights are indeed yellow, it'll be really obvious in contrast to the bright white of the paper. So in review of the object view, the key identifying features in the object view are the type of primary support, the image color or tone, and if there's any specific image deterioration present. Remember, when looking for image color, use daylight balanced light source and always look at the midtones and shadows. Other clues that may help you to narrow down a date or contextualize the object are clues within the subject matter of the image, the format, and if there's anything written or printed on the object, like a back print or stamp, a date, a name, or studio information. All right, let's move on to the surface view. The surface view includes characteristics visible with directional illumination and no magnification. What we're really looking for here is surface sheen. There are a couple of ways to see sheen. You can pick up the print and manipulate it under light, allowing the light to rake back and forth across the print. This video from Graphics Atlas is intended to mimic that action. So we're sort of tilting it underneath the overhead lights, if you will, to get the sense of what the surface sheen is. Or if you can't or don't want to handle the object, you can use a flashlight. Hold the flashlight about 4 inches above the print. Position yourself so you are looking straight down at the print from above, so your head is in line with the flashlight. If you see a ball of light that is the surface reflection of the print, to see that, what Erin would need to do would be to stand up and lean forward so her head is positioned directly above the light source. You'll want to play around with this and kind of figure out the best viewing angle so you can see the surface sheen, so you can see that little ball of light on something that has some gloss to it. Here's our visual guide for identification for surface sheen. Here we have divided surface sheen characteristics into 4 sheens, as well as included other important surface characteristics. Prints may be matte, semi-matte, glossy, or have a high gloss. On the right, differential gloss is where there is a difference in gloss between the shadows and highlights. Usually the shadows are glossier than the highlights. Some prints exhibit iridescence where the color of the sheen itself is pink and green, like a soap bubble or oil and water in the street. This iridescence can actually only be seen under fluorescent lighting. So in this case, you actually want fluorescent lighting. Silver mirroring is a sign of silver image deterioration. Bronzing is a term used for a phenomenon in printed out prints that looks a lot like silver mirroring, but it's not the result of deterioration. Silver mirroring is typically accompanied by other forms of silver image deterioration, like fading and yellowing. And this first example on the left is silver mirroring, and you can see that the image is also kind of a yellow-brown. So with bronzing, the shadows will be mirrored, but the rest of the image looked pretty good. So this third example in is actually bronzing. The image itself has not deteriorated. It looks pretty good, but the shadows look as if they have silver mirroring. Bronzing is also a term used for inkjet prints, especially pigment-based inkjet prints, which the color of the gloss itself is bronze. So here, the last two images, they're pigment-based inkjet prints, and the color itself of the sheen, right, the color of the sheen itself is this bronze color. In order to see these features, what you'll want to do is refocus your eyes on the surface sheen itself, on that ball of light, and not on the image. Silver mirroring, bronzing, and iridescence can actually be pretty subtle. They can also be really obvious, but they can be subtle. So as a refresher, surface texture and sheen are related. Incident light strikes the surface of the material and bounces to the eye. A very smooth surface, most or all of the light will bounce back, giving a glossy or high gloss surface sheen, as we see on the left. Plastic and glass supports are often high gloss. When incident light strikes a rough surface, the light will hit all those little bumps and diffuse out in all directions, giving a matte sheen, as illustrated on the right. If a surface has some texture, some of the incident light will bounce to the eye, and some will diffuse in all directions, producing a semi-matte sheen seen below. In the 19th century, surface sheen is a fairly good indication of materials and layer structure. One-layer prints, like salted paper, cyanotype, and platinum prints, are typically matte. The incident light is striking the paper fibers and diffusing in all directions, creating a matte sheen. That's what's shown in the top illustration. A two-layer print, as we see in the middle illustration, like albumin prints, or prints with a very thin baryta layer like matte collodion, are often semi-matte. The paper fibers are protruding through the binder slightly, creating a slight texture. Three-layer prints, as we see here with the thick baryta, are typically glossy. Late albumin prints can also be glossy. In either case, these have a very smooth surface, so nearly all the incident light bounces off, creating that neat ball of light. This guideline for identification does not apply to 20th and 21st century prints because the materials could be altered to produce a wide range of surfaces. It's important for characterization, though. Shown here are the layer structures of 4 different silver gelatin developed out prints and the resulting surface sheens. So we can see on the far left we have a print with a very thick baryta layer, giving us a pretty smooth surface. This one also happens to be ferrotype, so we get this neat ball of light. It's glossy. The second image we can see in the cross-section that has a thin baryta layer, so some of those paper fibers are protruding through and it has some texture to it, so we have kind of a semi-matte sheen. The next one is also semi-matte, but slightly less semi-matte, if you will. It also has a thin baryta. The example on the far right, the last one, has a thin baryta layer, but this one also happens to have matting agents. And if you remember from the 20th century, matting agents are those particles of silica or starch that are added to the binder or to the baryta, creating a really coarse surface, giving you a very, very matte sheen. So back to our sample objects. Each has a different surface texture, which produces a different sheen. Again, compare your print, or we'll compare this print, to the guide. We can see that object number 2 has a semi-matte sheen. So if we we image this, right, with that directional lighting, to give us the sheen, and if we compare it to our guide, we can see it looks semi-matte. Objects 1 and 3 are glossy, so they're in this sort of glossy range we can see. Object 4 is overall glossy, but it also has differential gloss. The shadows are glossier than the highlights. If we look in the area of the face where the shadow meets the highlight, we can see there's this difference in gloss. We compare it to our guide. Oh yeah, it definitely has differential gloss. So in review, with the surface view, we are looking for surface sheen characteristics. Make sure you are looking directly down at the print with your head positioned above the light source. Focus your eyes on the reflection of the sheen on that ball of light and not on the image. Let's move on to magnification view. Magnification view are characteristics visible with magnification, as you may have guessed. Depending on what you're looking for, you may want either even illumination or raking light. With this view, what we're looking for are characteristics of image structure and layer structure. Tools for magnification include a 10x loupe, a pocket microscope, and a stereo microscope. The first two are easily accessible. You can purchase these online or at any sort of photo store. The loupe and the pocket microscope are necessary tools for identification. I'll say it again. You need to have a loupe and you need to have at least a pocket microscope for identification. There are some processes, like photomechanical and digital print processes, that cannot be properly identified without magnification. Most loupes are about 10 times magnification, or 10x, giving you about this much detail. Pocket microscopes range. The image here is about 30x, or 30 times magnification. However, some pocket microscopes can do 50x or more. The microscope can give higher magnification. This image is about 50 times magnification, or 50x. Again, a good pocket microscope can get to this level of magnification. You only really need 50x. Anything higher than that is really too high usually. There are some techniques for using these tools. If you're using a loupe, use the technique shown on the left. Hold the cup of the loupe to your eye. Notice Erin is using her loupe upside down with the cup to her eye. This avoids putting the hard plastic of the loupe in contact with the print and will minimize risk of damage. Usually, when using a loupe, as you lean over the print, your head blocks the light from the overhead lights, making it difficult to see properly. The solution is to use a flashlight and hold it at a 45-degree angle, illuminating the area of the print that you want to see. Most pocket microscopes, seen on the right, have a built-in light you can use. With higher magnification, it doesn't actually work very well to hover above the print because you'll never keep it in focus. So we recommend putting down a piece of polyester sheeting first and lightly placing the microscope on top of the polyester to avoid abrasions. Use your best judgment though. Putting anything in contact with the surface, even with a plastic sheet, may not be a very good idea for some objects. Most pocket microscopes have a magnification zoom and a focusing ring. Adjust so the print is in focus and the magnification is between 30 and 50x. So you could see that here Erin has her plastic sheeting down. She's lightly placed the pocket microscope on it. She's adjusting the focus without pushing down on it with very, very light pressure. And she has it sort of set to the lowest magnification for this pocket microscope is 50x. If Erin were to want to look at a different area of the print, she would pick up the microscope and place it carefully back down rather than dragging it across the plastic sheeting, again to avoid abrasions. A stereo microscope is really best because you will never have to put anything in direct contact with the surface of the print. But stereo microscopes are pretty expensive. I recommend looking into getting one if you can, but if not, if you don't have the budget for it, just definitely go for a good pocket microscope. What you're looking for with these tools and light in this lighting angle is the image structure. The image may appear continuous in tone. You may also see pigment particles, or the image may have a distinctive pattern to it. With higher magnification of 50x, the image grain may be visible, particularly in dye-based colored photographs. This may take some practice. Looking at photographs with magnification can be visually kind of confusing. It can be tricky to establish what is part of the image and what is maybe just stuff on the surface of the photograph, like accretions or even retouching. When looking for image structure, always look in the midtone areas. There's too little image information in the highlights and too much in the shadows to properly see any kind of image structure. When we photograph, like you can see in our guide here, we tend to image the eye of the subject, particularly if it's a portrait. But what we're looking for is an area that has a highlight, a midtone, and a shadow. Typically the eye has that. Usually when identifying a process, what I'll do is I'll look in several different areas of a print, especially areas with sort of good midtones or a range of midtones. So I don't just look in one area, I'll kind of move around and look at different areas. As a reminder, most photographic images are continuous in tone. Photomechanical and digital prints have a pattern to them. The first thing to look for is whether or not the image has a distinctive pattern of dots, squares, squiggles, or something else, or if the image has smooth and continuous transitions between highlights, midtones, and shadows. We actually have 3 visual guides for identification for magnification for the image structure. This one shows the different possible image structures at 10x magnification. We have another one that shows image structure at 30x magnification. Again, with a little bit more magnification, we can see these image structures a little bit better in terms, especially with the patterned. And finally, we have a guide that shows image structure at 50x magnification. Notice we have another layer here. We have another kind of category here. With higher magnification, the image grain of some prints is visible. This may be silver conglomerates from enlarging a negative, or it can be the structure of the color image, like dye clouds or bleach halos. This can be a key identifying feature for color photographs. Back to our object examples, all 4 of our examples are continuous in tone. Notice the transitions between the tones are even. There's no distinctive pattern here. There's no dots, squiggles, squares, anything like that. So this 4th object, we already know it's a Woodbury type. We do know that Woodbury types are photomechanical, but they're sort of different from other photomechanical processes. It's pigment and gelatin, and so we can actually see that pigment particles are also visible here. The other pigment processes, like carbon, will also have pigment particles visible, and you may remember that Woodbury types and carbon prints are actually pretty difficult to distinguish from one another. Sometimes it's not even possible. Another way to look with magnification is with raking light. In this case, you can use your loupe in the same way with the cup to your eye, but hold the flashlight so that it's a 90-degree angle, raking across the surface of the print, as you can see Aaron is doing here. With the pocket microscope, turn off the built-in light and use the flashlight, again, at a 90-degree angle. Also, as before, put that piece of polyester sheeting down first. We have found that the polyester sheeting doesn't inhibit your sort of ability to see layer structure. It works just fine. What you're looking here are indications of layer structure, as I've just said. Can you see the paper fibers? And the point of that raking light is it really makes those paper fibers jump. They really sort of pop if they're present, if you can see them. So you're looking to see if you can see the paper fibers, how well can you see them, and where is the image in relation to the paper fibers? Again, we have a guide for this too. So let's review, and we'll come back to this guide. I'll say this a few times, but I want to point out that this is what we call advanced identification. This is probably the most difficult. So as a review, in a one-layer structure print, the image forms in the upper layers of the paper support. Therefore, paper fibers will be clearly visible and the image is in the paper support. A two-layer structure, or a print with a very thin varietal layer, the paper fibers are visible through the binder, but the image is in the binder suspended above the support. In a print with a three-layer structure and a thick varietal layer, the paper fibers are totally obscured, and of course the image is in the binder. Photomechanical and digital prints, the image material, the ink, is applied to this paper support, so the image is really on the paper. The paper may be uncoated, resulting in paper fibers that are visible, with the image sort of more superficial and on the paper. Coated supports may have a thin coating that is either clear or pigmented, but the paper fibers will still protrude. The image is above the paper fibers on the coating, but the paper fibers are still kind of visible. That's our center example here, and you can see where I'm pointing with the arrow, you can kind of see the paper fibers. They're not super obvious, but they're definitely there. Coated supports that have a thick coating, that have sort of a thick opaque coating, will totally obscure the paper fibers, which is what we have at the end here on the right. So going back to our guide, the first section at the top shows examples of one-layer structures in which the paper fibers are visible and the image is either in or on the paper, whether it's a photograph or photomechanical or digital. The middle section shows examples where the paper fibers are visible, but the image is suspended above the paper, either in a binder or on a coating. This indicates photographic prints that either have a two-layer structure or prints with a very thin varietal layer, or it can be a photomechanical or digital print with a thin coating. The bottom section shows examples in which the paper fibers are obscured, indicating three-layer structure with a thick varieta for photographs, or a thick opaque coating for photomechanical prints. Here are our 4 prints again. These were all imaged with 50x magnification and Raking Light. This is nearly equivalent to what you'll see with a good pocket microscope and Raking Light or a stereo microscope. Here we have objects 1 and 4 compared with our guide. In both examples, the paper fibers are visible, but where is the image in relation to the fibers? In both, the image is above the fibers in a binder. It may be difficult to distinguish between the image being in the paper fibers, suggesting a one-layer structure, and the fibers being in the binder, suspended above the paper fibers, suggesting a two-layer structure or even a three-layer with a thin varieta. I suggest looking at a plain piece of paper to get accustomed to what plain paper fibers look like with magnification. We really want to train our eye to know what paper fibers look like. This will help. This print number 1, has a binder and the image is above the paper fibers. Again, this is what we call advanced identification. If you're not sure, it's totally okay. This takes a lot of practice. It takes a lot of looking, but trust me, you'll get there. Sample 3 on the right is pretty straightforward. The paper fibers are obscured. We do see that we have some abrasions here. We even have some accretions. We're going to ignore those. We see that they're scratches. We're looking for the paper fibers and we don't see them. Sample 2 is a little more difficult to discern. The paper fibers are just barely visible. You know, we can kind of see them here and here. This suggests a thin varieta, but not like a super thin varieta. So like I said, this can be challenging. Another technique is to look at the edges and corners of the print where damage is most likely to have occurred. You may be able to see each layer if the various layers are lifting or if they're missing. So in this example here, here's the object, and we're looking at this section at the edge of the print itself. We can see the print is on a secondary support, so we're looking at the edge of the print itself. Here it is enlarged. On the bottom half here, This is that mount, right? That's the secondary support. Here we have the print itself. Here's the image material, is this sort of gray color, and along the edge we can see that the binder has lifted. There's some damage, and if you look here, we can see a piece of the binder is actually folded up, and stuck to that binder we see a little bit of baryta, but it's very thin. If you look closely, you can indeed see the paper fibers too, and then we have that support here. So looking here, we can go, oh, I think there's 3 layers, but it actually has a really thin baryta. So like I said, it's advanced ID. Don't get hung up. If you're not sure, it's totally okay. So in review, with Magnification View, we're using a loupe, a pocket microscope, or a stereo microscope, and we're looking for image structure. That is, whether the image is continuous in tone or has a pattern, and we're looking for layer structure. How well can you see the paper fibers? And where is the image in relation to the paper fibers? Next month, I'm going to take this methodology and vocabulary and show you how to use it with Graphics Atlas. Again, think of it like identifying plants. You don't have to know everything there is to know about every photographic process. You just need to know what to look for and have a good reference resource. We've been using this methodology and this vocabulary in our workshops with a lot of really great success. So I really hope that you'll join us next month, and I'll show you how to use it with Graphics Atlas. So thank you again to the National Endowment for the Humanities Division of Preservation and Access for funding this webinar and this project. Thanks to the Andrew W. Mellon Foundation for funding the content creation for Graphics Atlas. Again, join us next month, Wednesday, January 10th, same time, 2 p.m. Eastern Standard Time, for a methodology for process identification, part 2. I'll go ahead and answer some questions now. When you close out, a brief survey will appear. Please, please, please answer the survey. It's really short, and give us some feedback. Okay, I gotta take off my glasses here to see the... Okay, what is the difference between printed out and developed out? That's a silver chemistry, and so there's 2 ways in which to create a silver-based image. I would actually encourage you to look at the recorded webinars from the 19th century and the 20th century. Printed out means that the silver image forms directly with ultraviolet light, with sunlight. You can actually see the image print out, appear before your very eyes. With developed out, you get what we call latent image. You sort of plant the seed of silver image formation, but it requires an extra step. It requires a chemical developer to kind of push it over the hump into visible image particles. What do I consider a good pocket microscope? I knew somebody was going to ask me that. This is by no way an endorsement for any product, but we've been using, what are they, Carson pocket microscopes. Carson makes a really good one. I don't have the name of it, the exact product before me, but it's actually the one that was used in the illustrations. We've been using those. We're really happy with them. They're about $15 or something like that on Amazon, so it's a pretty good deal. The optics are pretty good for having what I'm assuming is a plastic lens. The optics are pretty good. I've been really happy. They claim 60x to 120x. I think it's more like 50x, and that's definitely keep it on the low side. Where can we get copies of the identification guides? Good question. If you go to www.graphicsatlas.org and you go into any of those tabs, the guided tour or compare, you'll see that there's a tab that says search, and you'll see there's actually a search function that's there, and next to each of those categories in the search function, there's a PDF of the ID guides. Again, I'm going to show you all of that next month and show you how to access those and use those. Just be careful. The color of your screen may not necessarily be calibrated, or if you want to print them out, that color calibration may not actually be quite right. The only really matters for the color one. We are looking into and probably will print some guides that you can purchase that will be printed properly so that all the colors are accurate and will be a really good reference guide. But for now, you can get them as PDFs on Graphics Atlas. Your analogy with identifying trees in the forest is a good one. Hey, thanks. Could we take this further? Botanists, I am one, cool, commonly use, uh, sorry, dichotomous, wow, it's a good one, keys, which take you through a progressive decision tree based on ID features. Would this be useful? Um, yeah, we have, and a lot of people actually have tried this. There have been a lot of iterations of this. I think the closest and the most successful is the pull-out chart from the care and identification of 19th century photographs. There's also a pull-out chart in Martin Juergen's digital print identification and care book. Um, but yeah, I actually, when I started this project, went through the exercise to kind of make a decision tree. The problem with the decision tree is that if you make a wrong choice, it can lead you down a rabbit hole that's like totally wrong. But I will say that our new search function is similar to that. When you compare your object with the guides and use the search function, you choose from the vocabulary that I actually presented to you today. Is your image, brown, black, purple, red? You're making a decision, right? You're saying, oh, mine's purple, red, and you can click that. And what the search function does is it'll filter out everything on Graphics Atlas that is not purple, red, and leave you only with the purple, red objects. So it's similar, but I'm thinking it more like when you're shopping and you're shopping on an online store and you only want men's pants. It's going to filter out everything that isn't men's pants. But yeah, the decision tree is something that a lot of people play around with, but no one's ever been successful with it. Hopefully someone smarter than me will be able to do it. Can you talk about developing out and printing out papers? Are these terms interchangeable or do they do different things? Yeah, developing out and printing out papers are very different. They look very different. Again, watch the 19th century webinar and watch the 20th century webinar. Those go into a lot more detail about the difference between printing out and developing out. That has to do with image formation. It has to do with the final possible colors of the final image. So again, it's silver chemistry. Printing out, the image forms before your very eyes. They're very, very small image particles, which in turn give you these kind of red image tones, which are then toned to give you something more pleasing with gold, and you end up with this sort of purple red. So our printing out often has this sort of purple red depending on toning. And then developing out, again, you have that sort of further chemical needed to create your image. Those form large filamentary image particles. The way the light strikes those particles and bounces back to your eye, you get black image tones, which of course can be toned other colors. But yeah, there is a difference. The image tones are very different. Also, developing out papers weren't really introduced until the very end of the 19th century and didn't really become popular until the 20th century. I think that's it. Great. Well, thank you all so much, and I encourage you to join us next month. Where I'll show you how to use these guides with Graphics Atlas, and use it as a reference resource. Cool. Thanks.